Assalamu alaikum. Again, I welcome all of you to the modern approach to concept of chemistry. As this is the first lecture, as in the introduction section, I have already discussed or said that what we will be doing in this course. Actually, our aim is to learn things and not to memorize or to rely a little bit lesser on memorizing things. We need to understand things, what actually is happening. So without wasting the time, let me start that the course. We will be studying energy. Okay, so you in a freshman courses you know that what actually energy is. So again, let me draw something. It will be clear to you that what I am talking about, in what sense we will be studying suppose we have these two charges. Okay, these are small point charges. This is positive charge and the other one is a negative charge, and they are a little bit let's say they are 1 centimeter from each other. There is a distance of 1 centimeter between them. 1 centimeter between them. Okay, and you increase the distance between them to 3 centimeters. These red lines, these are just showing the distance. They are very near to each other, they are far apart from each other. So the one in which the two charges, the positive and the negative charges, they are near to each other, we will call it case 1, and in the other in which these two charges are far apart from each other, we will call this a case 2. But what they say, the energy, the potential energy in the case 2 is more than that of the case 1. So we need to understand that how and why the energy of this system is less than this, or of the case 1 energy is the energy is less here and the energy is more here. So as you know that these two charges are opposite. One is positive, the other is negative. Here again a positive and negative. You know what a positive and negative do? What they do with each other? They attract each other. Okay, suppose they are the charges. Suppose they influence each other here at at distance of 1 centimeter and again at the distance of 3 centimeter. From the influence I mean that still they can attract each other. Okay, so now how can you increase the space between those two charges? You need to apply some force in order to separate those two charges from each other, because they are attracting each other. When they are attracting each other, so you need to apply some force against the attractive force in order to increase the distance between them. So you need to apply some force, and a distance is covered. In the first case it was 1 centimeter, and in the second case it is 3 centimeter. So what? So when you applied force, it covered distance, or the distance between them increased. So you applied work on it, or you did some work on those charges, and you pull them apart from each other. So you have done a work. So what if work is done? So what is then? But that work is now stored in those two charges as a potential energy. So your work is stored here as a potential energy. So this proves that the case 2 has more potential energy than the case 1. Okay, let's suppose both the charges are negatively charged or the same charges. Let's say, so for sake of understanding, if both are the same charges, plus or minus, okay. Let's say both are same charge. This is positive and this is positive charge, and as you know that the positive charges repel each other because both are of the same charge. So if you further decrease the distance between them, again what you have to apply force on those two charges. What will the force do? The force will make them closer to each other. Suppose they are 1 centimeter from, apart from each other. Let's assume that the distance between those two positive charge is 1 centimeter, and here it is 0.2 centimeters. Okay. So what you have done, you have applied the force. Now again a distance is changed, but this time you applied the force against the repelling force. You again work is done. So again the potential energy is stored in these two charges. Okay. Now in the same charges, when they are when you bring them near to each other, because they repel each other, their potential energy increases. But when they are opposite charges, when you bring them closer together, their energy decreases. So this is the concept of potential energy. As we just studied that the positive charges or the same charges, when they approaches each other, their potential energy increases, or when the opposite charges they approaches each other, their potential energy is decreased or lowered. When the opposite charges move away from each other, their potential energy is increased. So let me elaborate this thing or describe this thing with an example. Suppose we have an atom magnesium. It has its atomic number is 12. Electronic configuration is 1s2, 2s2, 2p6 and 3s2. Okay, so this is the electronic configuration of magnesium and its atomic number is 12. So now let us pick three orbitals from it, only the s orbitals. Let us pick the 1s orbital, the 2s orbital and the 3s orbital from this magnesium. So it has a purpose and you will understand it. Okay. Now as you know that this is suppose 1s orbital of magnesium. Suppose this is 1s orbital, and you know that the s orbital is just above the nucleus. Okay, here it is a nucleus, and what the nucleus has, it has 12 protons present in it. So I don't think so that it will be visible, but let's say it is 12 positive protons present in this nucleus. And this, what is this? This is 1s orbital. Okay. Now let's move to another orbital, a 2s orbital. Again it has a nucleus, and as you know that in the atom the orbitals are present one above each other. Okay. So it has again the nucleus, same nucleus with 12 protons. This is 2s orbital. Now let's move to another orbital. This is a 3s orbital of the magnesium atom. We are ignoring the 2p orbital for a purpose, intentionally. Again, these are the red things, these are the nucleus. The 12 mean it has 12 protons. Again the 2s orbital of magnesium is of the same atom. Again its nucleus has the nucleus of the 2s has the nucleus of magnesium has 12 protons. Again the 3s orbital, this is 3s, again it is in the same atom, the orbital is in the same atom, so it has 3 protons, 12 protons present in it. So let me draw it, those orbitals a little bit in combined form so that you understand it. Suppose this is a nucleus of magnesium, it has 12 protons present. This is 1s orbital, this is the 2s orbital. These are not shells, I am drawing the orbitals on one and other. This is the 3rd orbital. Okay, this is combined, this is how they are present in an atom. Again, you may be thinking that 2p orbitals are again present in the same atom, but let us ignore that intentionally, because I want to make you understand a very important concept. So let me write another things. The blue things, these blue balls, these are electrons. These blue balls, they are electrons, and these blue balls, they are electrons. So it is a little bit oblong. Let me write it in a little bit correct way. Okay, the nucleus is right in the center. Here it is a little bit off center, but in reality it is in a center. So this is 1s orbital of magnesium, because magnesium has 12 protons. This is the 1s, this is 2s, and this is 3s. Again I am repeating that this is not we are ignoring the p orbital right now. Okay, so what I want to discuss is the energies. So when you look at this thing, suppose I should write the protons with red. These red balls are protons, okay, and the blue things are electrons. Okay, both electrons. These are 12 protons and these are 2 electrons. Again I should write it like this a little bit. Okay, and here again I have to write it like this. So as you know that the protons are positively charged, the electrons, they are negatively charged. I'm sorry, negative, I should write, these are electrons. But what I want to show you is that the distance here, in this case, the distance between the positive and the negative is like this, and here the distance between the positive and the negative is this, and here the distance between the positive and the negative is this. I should exaggerate it a little bit more. Okay, so what is happening here? These are protons, nucleus. Suppose you extracted the nucleus out, and these are the electron. Here it has small distance, now it has a bigger distance, and here the distance is very large. So what those distances tell us? Two things. One thing is 1s orbital is smaller than 2s orbital, the 2s orbital is smaller than 3s orbital, or you can say in the same atom the size of the orbitals increases with the number of n, the principal quantum number. Here the principal quantum number n is 1, here it is 2, and here it is 3. So this has a large size. So what if it has a large size? So what? Here you can see that the distance between the positive protons, they are 12, and the electrons 2, here it is large, and here the distance is very small. Now it can give you an idea, as we discussed a little bit earlier, that when opposite charges are near to each other, they have lower energy. When the opposite charges are away from each other, they have high energy. So if we consider that concept, we can say that here the 3s electrons are high energy than 2s orbit electrons, and they are high energy than 1s electrons. So this is the concept which I wanted to show to you. Now if you write it in energy order, so this has 1s orbitals, so let us consider the electrons. These electrons are of lower energy. The reason, you know, because they are very near to the positive charge. Their potential energy is less. They are of a higher energy a little bit, because then they are higher in energy, these electrons, than the 1s electrons, because they are a little bit farther apart. These electrons are more higher in energy because they are a little more farther apart from the positive charge. The distance between the positive and negative is more. So two things we learn from this, that the sizes of the 1s orbital is very small, the size of the 2s orbital is large, and the size of the 3s orbital is very large. And the electrons in the 3s orbitals have very high energy, the electrons. So we can also write it like this. Suppose we want to write it in energy sense. This is 1s, this is 2s, this is 3s, and let's say the energy is increasing this way above. Okay, here the energy is increases. So the 1s electrons we write it on lower energy. The 2s electrons are higher in energy than the 1s electrons, and the 3s, sorry, I am writing it a big little bit, they are at the highest energy among the three, because this is the direction of energy. Energy increases upward, energy. Energy increases like this. 1s orbital is of lower energy, or the electrons, when they are present in 1s, they are of lower energy. The 2s are of a little bit higher, and 3s are a little bit more higher. Now you know that why they are, just because of the distance between the positive and the negative charges. Okay, so let us move to another example. Argon, Ar symbol. It's a noble gas and its atomic number is 18. Okay, so what is its electronic configuration? Its electronic configuration is 1s2, 2s2, 2p6, 3s2. Let me write this. And 3p6. Okay, now let us ignore the s orbitals of this atom, and let's go for the p orbitals. But again, as you know, that the p orbitals, they are three number which are perpendicular to each other. In perpendicular to each other means that they are like this in x, y, and z direction. Okay, suppose this is one direction, this is the other direction, and this is the other direction. Let us select only one orbital from each, 2p and from 3p. Okay, by conventional they take this as z. Okay, this is z direction. So let us select the z orbital, or the 2pz z orbital and the 3pz orbital. Okay, so let's say this is 2pz orbital. Okay, but let me again tell you one thing, that how this orbital look like. Generally, you know that the orbitals are arranged in such a way, these p orbitals. So this is the pz orbital. They are arranged in such a way that they are like this. Okay, but what is in between? This red thing, this is the nucleus of an atom. So the red thing is nucleus. So they are above. The two dumbbells are, let's say in this case, in the pz case, half is up, half dumbbell, and the half is below. And on the nucleus there is very little electronic density. Okay, so it is just like this. This is 2p orbital. Any p orbital has this shape. We will discuss the shape of the higher orbitals in a moment, but this is 2p orbital. In each p orbital, each p orbital is a double dumbbell. So what is there? It's the nucleus, and half is above and the half is below the nucleus. So what is in the nucleus? In the nucleus of argon, there are 18 protons present in it, and protons are positively charged. So let's compare the 2p and the 3p orbitals. But let me again repeat, the p orbitals are 3 in number, px, py, pz. Here they are again 3 in number, px, py and pz. So let's take one orbital and compare it with the other orbital of the 3p. One orbital from 2p and the other orbital of the 3p, and let's take the pz orbitals so that they are in the same direction, so you may know that what is how they look like. Okay, so right now let me write the nucleus very tiny with a red spot. Okay, what this red spot is, this is the nucleus. It has 18 proton present in it. What we are now going to write or draw, we are drawing a 2p orbital. Which 2p? 2pz orbital. Okay, this is 2pz orbital. Okay, and this is 2pz orbital, 2pz orbital, and it has again another p orbital. I have intentionally selected the argon because they have 6 electrons in this p and 6 electrons in this p. I will explain it in the next or the other lectures, that why I have selected with the same number of protons, electrons, the orbitals with the same number of electrons in it. Okay, suppose this one is nucleus, red dot. I think it is be visible, but let's say what this red dot is, 18 protons. And now what is there? 3s2. Let me erase this. So this is 3p orbital. What the 3p orbital has? They have electrons. Suppose they have, as you know that these orbitals, electrons are also present here, 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 here. But let us select one point in both the orbitals like this. Suppose both the electrons are right present here at the very tip of this orbital, and both are present here. The same I was supposed to draw for the 2s orbitals, or when we were comparing it, because these are, suppose this is 2s and this is this is 1s, this is 2s and this is 3s. Let me again tell you with reference to electron, these are the nuclei. 1s orbital of the previous example, 2s and 3s. And as you know that the electrons are here, 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 here. But let's say, because we are comparing the electron, so let's say that we just have a camera and we take a snapshot and both the electrons are here. Suppose it's not possible, and in this case both the electrons are here. Okay, so suppose they were here on that time, so then we just calculated the distance. It is not possible to calculate the distance, but from the orbital size you can know that this, what is orbital? It is the place or the space where the probability of electron is maximum. So the electrons are maximum in this thing, here, 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 and here, here, and here. Okay, in the p orbital, as you know that the electron near the nucleus are very less, and here, as it is a ball, it is a two-dimensional structure. The 2s is a ball, so the nucleus is inside. So above the nucleus, the electrons are very much dense. So let's come to the point. Okay, again, we learned two things from these two orbitals. One thing is the 2p orbital is small. The other thing is the 3p orbital is large. But there is another thing, and we learned that concept because I should not say, or I should not do the repetitive things, I should not repeat things, but for your understanding I am repeating those things. Here, as you see that the distance is less, here the distance is more between the positive and a negative thing. Positive and negative thing. What does this tell us? This thing tells us that the energy of 2p orbital is less and the 3p orbital is more. So because we will be studying a little bit complex concepts in the other lectures, that's why I am just starting from the very basic, and we will move ahead and we will move a little bit advanced, a little bit more advanced, a little bit more advanced, and then we will be studying that. And my aim is to learn or make you understand that what reality is. So we are studying energies, and the 2p orbital has less energy, 3p orbital has more energy. And again, in 1s, 2s and 3s orbitals, you also learned that they have less and high energies. What we learned from these two examples, we just learned that when positive or negative charge are away from each other, they have larger energy. Okay, so we just we studied the charges that farther away the positive and the negative charges are from each other. What happens? Their energy increases. And we just consider electrons as a sort of particles, but as you know that what electrons are in reality, they are waves. What the scientists say, they say that electron in an atom, it behaves like a wave. As you might have studied that electron can behave in a dual fashion. In a dual way. In a dual mean in double way or two way. It could be, electron can behave like a particle, okay, or it can also behave like a wave. So in an atom, the electrons behave like a wave. So we need to study the wave, that what is a wave and what are the parameters of the wave.